So let's take a look at, how about -10 divided by -2. And we want to illustrate and explain this answer. So to do that, I need to state what division means, and I have to state what integers mean. So first thing we have to ask ourselves to answer to illustrate and explain this is what does division mean? And we had, for integers, we had two main ways and kind of a third way that I'm not sure fits here, but we'll take a look. So division can either mean a set partition. That was what the book called the partitive model, or it could mean repeated subtraction, which they called the measurement approach. So repeated subtraction, book called it, so this is AKA measurement approach. All right, so I'll try to state what each of those means. If I say division means partition, then this would mean to split -10 into -2 groups. And then how many are in each group? Well, this is a problem right there, because I know what it means to split it into 2 groups, but I don't know what it means exactly to split it into -2 groups. So that's kind of weird. So I mentioned the other day in class that sometimes the set partition fails if we try to say we have negative groups. So that's something I can't do in reality. So the alternative approach is to try the repeated subtraction. Okay, so let's try repeated subtraction. Definition for division. In that case, what does 10 divided by -2 means? Well, there's a couple ways to say it. You could say from -10 subtract -2 repeatedly. Oops. Till we get to 0. So that's like direct repeated subtraction. The measurement approach is similar, but slightly different. So the alternative way, like for the measurement, would be how many groups of -2 are in -10. Groups -2 are in -10. Right, and that's more of what the book called the measurement approach. Okay, well, let's try it. So we'll start with a representation of -10. And I'm going to make a key on the side here. Let's say that right there is a negative. And this right here is a positive. And then don't forget 0 is an integer, and that's 2 of them together. And so that would be a 0. So I have to state what division means, right? And this is what division means. And then I also have to state what it means to be an integer, and which means I need to make a key for what's a negative, what's a positive, what's a 0. And you could use colors, you could use pluses and minuses. Those were the 3 ways we went about doing it. So starting with -10, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need to then look for groups of -2. So I'm just going to redraw that over here. Well, you know, here's a group of -2, and here's a group of -2, and there's a group of -2. So I have a whole bunch of them, so I'm just going to isolate them. there's 1, 2, 3, 4, 5. And I could have done it all in one picture, but sometimes I like to separate it out to explain my train of thought. And remember, I don't know what you thought when you wrote this stuff down. All I know is what you wrote. So look back at what you wrote after you wrote it down and say, well, you get what I was thinking? So the next I have to say, okay, there are 1, 2, 3, 4, 5. So now I set up, you know, here's what I think I'm starting with. Here's my illustration. Then I need a conclusion based on that. So based on this right here, I think there are 5 groups of, let's just, you know, -2 in -10, period. So -10 divided by -2 is equal to 5. Now, we can certainly plug that into a calculator, and the calculator would tell us 5, but why does the calculator come up with a 5 there? Okay, it has to be based on some physical model, and this is one physical model that justifies why the answer has to be 5. This is kind of like one of the best approaches to that. You could do the repeated subtraction, like show how many times you can subtract 2 from -10, and you should be able to show that you can do it 5 times. So that would be another approach, using that green approach right there. And as far as illustrations, right, though, I didn't mean to cross that out. These are the main 2 ways to illustrate it. I can illustrate it with sets, or I can illustrate it with subtraction. The other model we had was the missing factor model, but that's not an illustration. So let's just review that for fun. Missing factor model for division. And this was really good for working with 0. So if I just try to take -10 divided by -2, I would say, okay, that equals what? Question mark. We rewrite it with a factor, which means multiplication. So when I rewrite it, as multiplication is what the missing factor model says. That would say what times -2, and I guess that needs to go in parentheses, is equal to -10. Oops. And we have some rules for multiplication that if the answer for multiplication is negative, then we must have multiplied a negative times a positive, or a positive times a negative. That was our algorithm. So since the 2 is already negative, this number here has to be positive, and 2 times 5 is 10, so the answer must be 5. 5 times -2 equals -10. So -10 divided by -2 is 5. The problem with this model, though, is there's no illustration here. So we're missing an illustration. So that wouldn't properly answer the question I asked, because I want an illustration. So I would say you either have to do a repeated subtraction or use what I call the groups in approach, the measurement approach according to the book. All right, excellent question. That is definitely a challenging one. All right, other questions from y'all?